During this session on acceptance sampling, I will be discussing in detail the variable sampling plans for controlling process parameters. This point already I have explained in the previous lecture sessions. So, this is essentially we are referring to type 1 variable sampling plans. So, we will explain the basic concepts, we will explain that why it is needed, what are the the parameters of such the variable sampling plans, and then how to design such a variable sampling plan. Okay. So, what are the conditions to be known, and what are the criteria to be known, and if you use such a variable sampling plan, what are the advantages you may have. Okay. So, you will get a it's a clear cut idea that under what situation a variable sampling plan of this category, of the type 1 category, is recommended. Now, these plans are used when controlling of average quality or the variability of quality related to a product or the process is a concern. Average quality, that means the controlling say the process parameter, that is the average, okay, given by the average, or the process parameter may be the standard deviation, and that is why you have mentioned in general a term called variability or as a dispersion. Now, the limits of the product with the quality characteristics are submitted in lots of batches. Is it okay? That means here that means what you have mentioned actually, that is the lots of product with that means here this the product with the quality characteristics are submitted in lots of batches. That means these quality characteristics which we refer to, that means the limits of these quality characteristics must be known. For developing the plan, it is assumed that the determination of quality characteristics under consideration is normal. That means it is assumed that the distribution of the quality characteristics under consideration is normal. Is it okay? So, that is we assume, and here the 4 cases are considered, like I have already mentioned that what are the four cases under type 1 variable sampling plan. So, the case 1 is variable sampling plans for controlling process parameters. The case 1 is quality characteristic is of single specification limit type and the standard deviation is known. So, that is case 1. Now, what are the parameters? The parameters are the sample size n and acceptance limit, the notation is x a bar. So, this is capital X a bar. Okay. Now, how do you explain the working of such a sampling plan? Is it okay? So, what do you do when the sample size is known? That means a sample of size n is drawn from the lot, arrange the individual characteristics as obtained from the sample, arrange that means you measure the individual values of the quality characteristic as obtained from the sample. Is it okay? That means you calculate the average, you collect the individual values of the quality characteristics as obtained from the sample, and then the average is computed at x bar. Is it clear? For lower specification limit case, if x bar is greater than x a bar, this is basically called the acceptance limit. Is it okay? So, what will be the value of the acceptance limit you are going to determine when you design the sampling plan? So, if you come across a lower specification limit case, and if you find that the sample average, that is x bar, capital X bar, is greater than capital X A bar, the lot is accepted, otherwise the lot is rejected. Is it okay? So, now this is basically if x bar is greater than x A bar, the lot is accepted. For the upper specification limit case, if the sample average given by x bar is less than x A bar, the lot is accepted, otherwise the lot is rejected. Is it okay? Now, the question is, that means here it is the single specification limit case, and your objective is to control the process average as given by x bar, and what you assume that the distribution of x bar is normal. Is it okay? So, here what you find that first you have to specify the conditions, and these conditions are to be satisfied, and in majority of the cases you specify 4 conditions. What are those 4 conditions, or maybe just the 2 conditions? So, what are these conditions? First you specify, that means you design the sampling plan in such a way that the conditions are satisfied. You need to specify the conditions to be satisfied. This I have elaborated. Against good quality x1 bar, the probability of acceptance is 1 minus alpha, and similarly against bad quality x2 bar, the probability of acceptance is beta, right. You need to consider the distribution of x bar. Is it okay? As already pointed out, it is assumed that the central limit theorem is valid. I presume that you know what is a central limit theorem. The central limit theorem is explained most simply as that whatever may be the distribution of x, the distribution of any statistic of x, say the average, say x bar, or the standard deviation of x, is it okay, like say s, is normal or is approximately normal when n is large. So, this is the statement of the central limit theorem, and in majority of the cases when x, the value of x is dependent on several the factors, okay, it is basically is affected by, it is a response variable essentially, and this response value of the response variable is dependent on several other factors. These factors are occurring in the the upstream stage. So, if this is the condition, so and you produce this units in large number, that means the physical basis of say normality assumption is there, and that is why the central limit theorem is valid, and hence x bar is assumed to be normally distributed. Is it okay? Relationship of x1 bar, x1 bar is considered to be a good quality, x2 bar is considered to be a bad quality. So, how do you represent the relationship of x1 and x2 to x A bar? So, what is x A bar? That is the acceptance limit. Now, this relationship you can represent with the help of a particular figure. So, what you have over here, that means when you refer to the distribution of x bar, you say that this distribution is a shifting. Is it okay? So, when you achieve a good quality given by x1 bar, so this is the distribution, and this particular line is referred to as x A bar. So, this is x A bar. So, x A bar is basically the acceptance limit, right, and what you find that there is a probability of alpha, like say that even if the quality is say the quality, very good quality you get, but there is a possibility of its rejection. So, that is basically the producer's risk, and when, so suppose the value changes to x2 bar and x2 bar is considered to be a bad quality, what do you find that you compare x2 bar with xa bar, that is the acceptance limit, you find that this value, this is the area under the normal curve, that is existing, this area beyond xa bar. So, this line, this vertical line is xa bar, the acceptance limit. So, you will find that this is the probability of acceptance. That means, even if there is a very bad quality you achieve on an average, you will find there is a possibility of its acceptance, and that is beta. Is it okay? So, this way you explained the relationship of x1 bar and x2 bar with xa bar. Is it okay? And here obviously you are dealing with the distribution of x bar. So, as per the central limit theorem, obviously the variance of x bar is sigma upon root n. So, what is sigma? Sigma is basically the standard deviation of the process. Is it okay? So, how do you determine n and x bar? Against the tail area of alpha. So, you refer to the previous figure, what you find that you compute the z alpha, that means the standard normal variate, okay, against a tail area of alpha. So, that is xa bar minus x1 bar divided by sigma upon root n. That means the difference from say the good quality, and express this difference in the standard deviation units. So, what is the standard deviation over here? That is sigma upon root n. What is sigma? Sigma is the process standard deviation. So, you will find the way it is computed z alpha will be negative. Is it okay? Because this is negative. Against tail area of beta, again you refer to the previous figure, you will find that the standard normal variate, that is the z beta, is equals to xa bar minus x2 bar divided by sigma upon root n. So, obviously xa bar is greater than x2 bar, okay, in the figure. That is why this value is positive. So, z alpha is negative, z beta is positive, the way we have computed. Solving for unknowns, now there are these two equations you have. So, how many unknowns you have? The unknown is n, that is the sample size, and unknown is xa bar. What is xa bar? That is the acceptance limit for a single specification limit case, and it is a single sampling plan. Is it okay? We are not using double sampling plan when we refer to, or when we use say the variable sampling plan. But in certain cases definitely you can also go for double sampling plan. Is it okay? But right now we are not discussing double sampling plan in the variables category. So, solving for unknowns, you get an expression of n. Is it okay? You can solve these problems, okay, solve for n and solve for x bar. So, what is the expression for n? That is z beta minus z alpha into sigma divided by x1 bar minus x2 bar. This is good quality, this is the bad quality, and this is a square to the power 2, and xa bar is equals to z beta x1 bar minus z alpha into x2 bar divided by z beta minus z alpha. Is it okay? Now, we will take an example, a numerical example, so that the concept is made very clear. Ammonium nitrate is shipped in 500 kg bags. The lower specification for the concentration of nitrogen is 13%, lower limit. That means the value must be greater than 13% or more. The distribution of the concentration of nitrogen is known to be normal, that is the assumption, normality assumption holds, with a standard deviation of 1.5%. Find a variable sampling plan that satisfies the following conditions. Is it okay? So, what are these conditions? Like the batches with a mean of 2.5 standard deviations above the lower specification limit should be accepted with a probability of 0.95. So, what is the producer's risk? Producer's risk is 0.05, even if the quality is extremely good. And the second condition is batches with a mean of 1.5 standard deviations above the lower specification limit should be accepted with a probability of 0.10. That means what is this probability? This probability is basically the consumer risks. That means even if the quality deteriorates, is it okay? You will find that there is a possibility of acceptance. So that is the consumer risk. So first, what you try to calculate? You calculate the good quality. You estimate that what is the value of x1 bar. So what is x1 bar? That is LSL plus 2.5 standard deviations above the lower specification limit. So what is the lower specification limit? Lower specification limit is 0.13, that is 13%. So 0.13 plus 2.5 times into sigma. So what is sigma? That is 1.5%, that means 0.015. So 0.015. So the value of x1 bar is 0.1675. And similarly, the value of x2 bar is LSL plus 1.5 sigma. So LSL is 0.13, sigma is 0.015. So you get a value of x2 as 0.1525. Fine. Next, what you do? It is given that 1 minus alpha is 0.95, x1 bar is 0.165, beta is 0.10, I have already explained, x2 bar is equals to 0.1525. So now you refer to the standard normal table, and in any textbook on quality you will find as an appendix the standard normal tables are provided. So please refer to those the standard normal table, and you also must learn how to read the values, okay, from the standard normal table. Is it okay? So Z alpha is equals to Z 0.05. So this is producer's risk. So if you refer to the standard normal table, you get a value of minus 1.645. Is it okay? So I have already mentioned that the way we have computed Z alpha, so it is negative. That's why it is minus 1.645. How do you compute Z beta? Again, you refer to the standard normal table. So here the value of beta is 0.10, that is Z subscript 0.10. This is the notation you use. And if you refer to the standard normal table, you will find that against the tail area of beta, this value is 1.282. Is it okay? So the value of Z. Now you apply that formula for n, and you substitute these values in this particular formula. So ultimately the value of n you get as 8.57. So obviously it is a sample size. So you go for round it up, and this is the integer value, next higher integer, that is 9. So sample size is just 9, less than equals to 10. As I have already pointed out, in majority of the cases the sample size for the variable sampling plan will be less than 10. So what is XA bar? Again you use that formula, okay, you substitute all these given values, and ultimately you get a value of 0.1591. So you just refer to this particular figure. X1 bar is known, this value is given. X2 bar is also you have computed, that is 15125. XA bar, that is the value is 0.1591. So this value is 0.1591, and this is alpha, that is 0.05, and this is beta 0.10. So we are referring to the distribution of X bar. Is it okay? So exact values of X1 bar, X2 bar, these are known. Now we are referring to the case 2. That means the quality characteristic is of single specification limit type, and the standard deviation is not known. Is it okay? So this case also you frequently come across, right? Particularly when you come across a situation which is a new one. Obviously you may not have a sufficient past data. So values of x1 bar, 1 minus alpha, x2 bar and beta are specified or known. So this is your starting point. You cannot deviate from this condition. Now what is known, that the sampling distribution of this particular statistic, that is x bar minus x1 bar. So what is x1 bar? X1 bar is basically it's referring to good quality. Okay, so the average is of good quality, that is x1 bar, divided by s by root n. What is s? S is the sample standard deviation, okay, and the sample of specified size. Now, sampling distribution of this particular statistic is approximately a t distribution with n minus 1 degrees of freedom. Is it okay? So, this is the statement you have, and this is your assumption. And now, whenever the standard deviation is not known, that means the normality assumption is not valid. So, if the normality assumption is not valid, so you have to search for other kinds of distribution. Is it okay? In non-normal condition. So, that is essentially the t distributions we refer to. But here the problem is, at this point in time, when you do not have you don't know what is the value of n, the sample size is not known, because you have not yet designed the sampling plan. So, how can you calculate the sample standard deviation? So, as is not known, you cannot compute x bar and s. You have to search for an alternative. Okay. Neyman and Towarska, through their empirical study, construct OC curves for this case for different values of n based on t statistic for alpha equals to 0.05. That means many years back in 1936, they conducted several sorts of experiments, and after analyzing those experimental data, now they could construct the OC curves when alpha is equals to 0.05. That means we are referring to this particular empirical study and its finding, and it essentially a plot of PA versus lambda. Is it okay? So, how do you define lambda? So, the lambda is defined as x1 bar minus x2 bar absolute. That means the difference between x1 bar and x2 bar, and this is in the standard deviation unit. So, what is the sigma hat? The sigma hat is an estimate of sigma, which is going to change. Obviously, there could be a starting value of sigma hat, and as you collect more number of data points, you revise the value of sigma hat. Is it okay? So, this way you define lambda. Is it okay? So, they have constructed this OC curve, and what they have found, that the shape of the OC curve depends on the sample size. Like say this is the probability of acceptance, okay. So, that is PA versus the parameter, that is lambda. Now, when n equals to 2, the curve is really flat one, whereas n becomes 30. Is it okay? That means sample size 30. They have done a lot of experiments on this. You will find that the curve becomes very stiff. So, this is also an OC curve, and these OC curves they have constructed several such OC curves like this one. They have constructed at a value of alpha equals to 0.05. So, if PA, that means the probability of acceptance, is set equal to beta, the sample size can be found when lambda is known. That means first what you do, when x1 bar and x2 bar, these two values are known, sigma hat you specify, and then you get the value of lambda. So, suppose lambda is here, and then you set the probability of acceptance at beta value. So, here the beta value is 0.10, that means this is 1. So, then what you do, you just have this is the horizontal line you draw, and this is the vertical line you draw from the estimated lambda. Is it okay? And this is the point of intersection. Is it okay? It falls on a particular curve, and against that particular curve, what is the value of n? Is it okay? So, this is the procedure you follow. So, when the sample size is known, that means with this approach you will come to know what is the sample size. So, when the sample size n is known, the decision making process is as follows. Compute this sample statistic. Now, there is no problem, because x bar will be known because n is known, s is also known because n is known, because the sample standard deviation, that means n values you have already collected. So with these n values you can calculate the sample standard deviation. X1 bar is already specified and n is known. So this actual value of t you can calculate. If LSL is given, the lot is rejected if this condition holds, and if USL is given, the lot is rejected if t is greater than t1 minus alpha n minus 1. So where t alpha n minus 1 and t 1 minus alpha n minus 1 are the 100% and 100 alpha percentage and 101 minus alpha percentile points of t distributions with n minus 1 degrees of freedom respectively. Is it okay? So 100 into alpha and 100 into 1 minus alpha for LSL and USL case respectively. Is it okay? So what is case 3? Case 3 is the quality characteristic is of double specification limits and the standard deviation is known. So what you have here, that means when it is a double specification limit case, that means against USL against LSL, there could be the two bad quality values. So they are specified as X2 L bar and X2 U bar with the consumer risks of beta and a good quality X1 bar with producer risk of alpha, and they are to be specified. So the OC curves passes through 3 points: 1 minus alpha X1 bar, beta X2 L bar and beta X2 U bar. So this is the conditions you impose. Unless otherwise specified, X1 bar is the midway between X2 L bar and X2 U bar. So lower and upper acceptance limit. The parameters of the plan are n equals n, that is the sample size, upper acceptance limit and the lower acceptance limit. Is it okay? Because we are dealing with the two-sided specification limits or the double specification limits. So what is the working? A sample of size n is drawn from the lot. Average of individual values of the quality characteristics x bar is obtained from the sample, and this is computed at x bar. If x bar lies in the range x LA bar and x UA bar, is it okay? That means the range specified as the upper lower acceptance limit and upper acceptance limit, the lot is accepted, otherwise the lot is rejected. So this is the working, and this is basically we are explaining the relationship between say X2L bar, X UA bar and X1 bar, as well as XLA bar and XUA bar. So this is just an extension of the single specification limit case, double specification limit case. So instead of having just one bad quality, you have one bad quality over here, another bad quality over here. Is it okay? So assuming distribution of x bar as normal, the relationship between various parameters for the plan is shown by the following figure. So okay, so we are considering distribution of x bar. That means an x1 bar is the midway between say this one and this one. So when you have good quality, so you have the consumer risk as alpha, that means on one side is alpha by 2 and the other side is again alpha by 2. And when you either you have quality here, bad quality over here, or bad quality over there, in both the cases you will find that the probability of acceptance is beta. Is it okay? Consumer risk. So the following equations are obtained. That means this is against the tail area of alpha by 2 on one side, on the other side similarly against a tail area of beta on one side and on the other side. So you have all these expressions. Okay, so the standard normal deviates against the tail areas of say the alpha by 2 and beta you computed. So you have 4 equations and 3 unknowns. So there are 4 equations. However, one of these 4 equations can be derived from the remaining 3 and considered redundant. Is it okay? So that means there is the dependency. That means if I write down the first three equations, you can derive the fourth one. So what you try to do, that means all these equations are all these 4 are not independent. So what you do, make sure that any one of these is removed and with the remaining 3 equations, okay, simultaneous equations, you can definitely solve for 3 unknowns, so that is n, xla bar and xu bar. So this is a numerical examples. So these numerical examples you please go through, and whatever the steps we have explained in deriving the expressions for the parameters for the double specification limit case, when the objective is to the control the process average, all these steps we have followed with respect to these numerical examples. Is it okay? So ultimately you have three say the parameters in this case, and follow the steps meticulously, and I am sure your understanding will be appropriate. So the case 4, I will just refer to the case 4. So the case 4 is quality characteristics is of double specification limits type and the standard deviation is unknown. So you need to refer to a number of case studies related to development of such sampling plans. So there are many textbooks, the textbooks which you are referring to. So please go through those textbooks. You will find the several such case studies are derived, and the standard deviation is unknown. That means you will be referring to those empirical studies, and there are certain the formulations or the formulas you have that always you can use. Is it okay? So these are the references we have.